We want to find the remaining roots of the polynomial given that x equals 5 is a rational root. So the first thing we'll do is we'll use synthetic division to divide out x equals 5, and then we can use the quadratic formula to solve the rest of what we have left. So the first thing I'm going to do is I'm going to set up synthetic division, and I do not have to switch the sign of x equals 5 because it is a solution, it's a root. The only time you have to switch the sign is when you are given a factor. So like if it said x plus 5, then we would switch the sign. But as it is, when you're given a root, you do not change the sign. So now I have to put in all my coefficients. So the coefficient of x cubed is 1, then my next coefficient is -2, -3, and -60. Because I am told that this is a rational root, 5 is a root, when I do synthetic division, I should get 0 as my remainder. If I do not get 0 as a remainder, it means I made a mistake somewhere in my synthetic division. So I'm going to bring down the 1, and now we're going to multiply and add until we get to the end. So 5 times 1 is 5. Now I'm going to add down, which is 3. 5 times 3 is 15. If I add down, I get 12. 5 times 12 is 60, and if I add down, I get 0, which is exactly what I wanted. When you do synthetic division, every time you divide out one of your roots, your answer decreases by 1 degree. So since our original exponent was 3, that means that my answer would start with x squared, then x, then my constant term. But remember that now that I have a quadratic, so what I really have would be x squared plus 3x plus 12, and that's what I'm now trying to solve. Now that I have a quadratic, I can use the quadratic formula. So essentially what happens is these three numbers become my a, b, and c to use in the quadratic formula. So I'm going to set up quadratic formula, which I'm going to write here, -b plus or minus the square root of b squared minus 4ac over 2a. So now I'm going to take the a, b, and c values I got from synthetic division, and I'm going to plug them into the quadratic formula, and that will give me the remainder, my remaining two roots. So I have -b. b is positive 3, so it changes signs to negative, plus or minus the square root of 3 squared minus 4 times 1 times 12, and that's all over 2 times 1. The next thing that I would do is take everything that's under the radical and put it into your calculator to figure out what it gives you. When you put that into your calculator, it gives you -39. So I'm going to rewrite this, but I'm going to replace everything under the radical with -39, and I think it'll make it look a little bit less overwhelming. 2 times 1 is 2, so I'll replace that too. So now all I have to do is simplify the -39. I could do a factor tree with 39. 39 is 3 times 13, but both of those are prime numbers, meaning I can't break them down anymore. So there's no way for me to find a pair of numbers that I could take out of the radical. So that means the 39 is going to stay underneath. However, the negative will turn into an I on the outside of the radical. So I have one more step to simplify to get my final answer. So I have -3 plus or minus. I'm taking I out where there was a negative underneath the radical. The 39 stays, and then I have 2. Now the last thing I need to check is whether or not all three of the numbers on the outside could be simplified. So I have a -3, I have technically a 1 in front of the I and a 2. I can't simplify, I can't reduce those by anything, so that means our final answer is this right here. Now remember that this represents two answers because I have a plus and a minus. So those are two of my answers, plus the third solution that I was given at the beginning, x equals 5. So those are my three answers to this, the three solutions to this function. And if you look at my highest exponent up here that I have circled in white, it was also a 3. So it's also a good way to double check that you have the correct number of answers.